So, hi everyone, I am Arvine Jane Del Carmen from BSIS 2A. So, this time we're going to talk about the sorting algorithm. So, first, basically, what is sorting algorithm? So, which means the sorting algorithm is the process of arranging a list of elements in a particular order, ascending or descending. So, for example, of a list of words could be sorted alphabetically or by length. So this time we're going to discuss some of the most common sorting algorithms. So first we have the selection sort. Excuse me. So selection sort. So selection sort is a simple sorting algorithm. So this kind of sorting algorithm is uh, an in-place comparison-based algorithm in which the list is divided into two parts, the sorted part at the left end and the unsorted part at the right end. So initially, sa the sorted part is empty and the unsorted part is the entire list. So another strategy of selection sort is in which we find the smallest element in the iteration in each iteration and place it in the array starting at the first index. So as a result, a selected sort is split into sorted and unsorted subarrays. So the smallest element is selected from the unsorted array and swapped with the leftmost element, and that element is becomes the part of the sorted array. So this process is continuous moving unsorted subarrays, uh, unsorted array boundary by one element to the right. So these are the process or steps on selection sort. So first we have the step one is we have the set the minimum to the first location. So the second, search the minimum element in the array. So third is swap the first location with the minimum value in the array. So step 4, assign the second element as minimum. Then the last is repeat the process until we get a sorted array. So basically, understanding naman kaayo. So this process is balik-balik ko lang jud na to siya hantod makuha nato ang sorted array or kanang until kanang like ma-arrange na siya to smallest one to the greatest one. So we have two examples here in selection sort. So first, consider the array as 10, 5, uh, 10, 5, 2, 1. So this is the unsorted uh, given. So uh, the first element, so as we can see, the first element is 10. So the next part, we must find the smallest number from the remaining array. So the smallest number is number from 5, 2, and 1 is 1. So ato ang uh, smallest number is 1. So we replace 10 by 1. So the new array is 1, 5, 2, 10. So again, this process is repeated. So until matuyok na nato siya, like kuha na nato siya, makuha na nato ang sorted array. So ato ang final sorted array is 1, 2, 5, and 10. So let's proceed to the second example, which is we have the array um, 42, 16, 84, 12, 77, 26, and 53. So this is the unsorted given. So as we can see, the smallest number is 12. So swap into the first element in the structure. So bali na to siya into the first element. So in the data that remains, 16 is the smallest and it does not need to be moved or swap. Dili na siya kailangan kay siya man ang ikaduha nga smallest number so in the element. So the next is 26. So and it is swapped into the position into the third position. So the next is 42. So it is already in the correct position. So dili na nato siya ilabdan. Okay. So the next is the 53. So the 53 is the smallest number in the data that remains and it swaps to the appropriate position. Okay? So swaps siya sa 77. So the of the two remaining data items, 77 is the smaller. So the items are swapped. So we have the final sorted array, which is 12, 16, 26, 42, 53, and 77 and 84. So the selection sort is now completed. Okay? Muna siya ang final. So let's proceed to the second sorting of algorithm. We have the insertion sort algorithm. So in insertion sort algorithm, so if every iteration moves an element from unsorted portion to sorted portion, so until all the elements are sorted in the list. So here's the step-by-step procedure or process in the insertion algorithm. So we have step 1 is assume the first element in the list is in sorted portion and all the remaining elements are in sorted portion. So step 2, take first element from the assorted portion and insert the elements into sorted portion in the order specified. So step 3, repeat the above process until all the elements from the unsorted portion are moved into the sorted portion. So we have a example here in insertion. So we have given unsorted. We have 5, 3, 1, and 6. So 3 is less than by 5. So swap na to siya, no? So since 3 is the first element after the swap, we move on. So 1 is less than 5. So swap pa din. So the next is 1 is less than by 3. So swap natin kay mas mas gamay man si 1 kaysa sa 3. So since 1 is now in the first element, so we move on. So since 6 is less greater than 5, so we won't perform a swap kay mas dako man si 6 kaysa sa 5. So na naman siya sa iyahang position, so dili na nato siya kailangan i-swap. So we have the final array 1, 3, 5, and 6. So the array is now sorted. So we have another example of insertion. So wala na nako siya gibutang. So we have the given, so unsorted, wala pa siya nakakuan. So we have 7, 1, 23, 4, and 19. So consider the first element as a unsorted as there are no other elements on its left hand side. So look at the next unsorted element is 7. Next unsorted element is 7. So compare it with the sorted elements, which is 1. So 1 is less than by 7. So yes, kay mas gamay man si 1 kaysa 7. So balik, swap na to siya. Swap na to. So 23 is less than by 7. So no pa din. So 23 is less than by 1. So no. So no swaps in this selection or iteration. So 4 is less than by 23. So yes. So check the next number. So we have 7. So 4 is less than by 7. So yes. So check the next number again. So 4 is less than by 1. So no. Di na to siya i-swap. So the correct position of 4 is the current position of 7. So shift all the elements from 7 to 1 position ahead. So 19 is less than by 23. So yes, so check the next number again. So 19 is less than by 7. So no. So the correct position of 19 is the current position of 23. So again, shift the elements 23 one position ahead. So the entire array was is now sorted. So we have 1, 4, 7, 19, 23. So this array is now sorted. So as we can see, so insertion has a best case running time and is a good sorting algorithm to use it if the input list is already mostly sorted. So for larger or more unordered list, so an algorithm with a faster, worst, and average case running time, so such as merge sort would be a better choice for a larger or more unordered list, so an algorithm.
So I think that would be all for my discussion. I hope you guys understand and it would be a good presentation, no? So I hope you guys doing well and have a good health. So thank you everyone and God bless. Keep safe.